Good morning, guys. Today we'll start part number two of how we can plot differentiable graph in the Matlab. So last class in the part number one of our Matlab lab, we tried to plot some very basic plotting here. So what we did in the part one, so what we did in the last class, see, suppose I want to plot the value of x. For example, the x take the values from 0 to, suppose this one to represent the increment in the MATLAB language is 100. Okay. Now, this one to represent the space, right? Space size here. This represent the space size. If I put semicolon here, the data is not going to display in the command window, right? Data not displaying, right? It is not displayed of the data. So x will take the value from 0 to 100. The space will be 111. Okay. Now suppose if I want to plot y, right? Suppose it is the function of sine, so I have to put like this. Again, I put here semicolon. This semicolon represented data is not displayed in the command. Now, simple, if I want to plot here, this is the plot command. I can plot here x, comma, y. Then I can get here a graph like this. This is the graph represent x and y. Let us come up here in the Matlab. Same thing if I want to do in the Matlab here. So this is the command window in the Matlab, whatever I have displayed here. This is called a command window, but we are not doing the programming in the command window. The command window, basically, we try to give the commands. For example, if I want to input some values, then I can use the command window. If I want to run some programs, then I can put the file name only, then the program will be run automatically here. So to write the program, we use this as new script. This is called also editor, right? If I open the new script here, one window is open here. This window is called the new script, and this is called the editor. From this windows, if I write the program, then the file will be set in the .m format. Sometimes this is also called the m file. For example, let us try to plot. So we took x is taking value from 0, okay, column, okay. 1 represent the increment, right? Again, column here, I have put it here 100. This semicolon, I put it here. I don't want to disclose the data set on the command, so I put a semicolon here. Now, if I define another variable, which is y is equal to, suppose, sine of x, sine of x. Now here, if I put semicolon here, if I put here semicolon, then the value of sine x is not going to be displayed. For example, let us try to display this one, and we try to plot it after that. First, let us run the program. If I want to run, then I have to save it. If I save it this one, so this type of case will be here. Now, suppose I put the file name as a test2, suppose test2. Now I can decide, suppose in the desktop, I can put here. Now, suppose you can create any of the folder here. Suppose I have one folder, numerical method lab here. I have created here test2. So I save here. Okay. Now, x will take the value 0 to 100 with the increment is 1. Y is the function of x, means I can get the sine value of x. Now, if I run this program, look here. In the command window, you can see in the command window. Let's look in the command window. Look here. The value of x 0, 1, 2, 3, 4, 5, 6 up to it is 100. Have you seen here the increment are 1, 1, 1, 2, 3, 4 up to 100. Next is that y. What is the y? y is the function of x, which is a sine functions. Look here, I can get the value of y is 0, all the value of the sine functions. Okay, so I can get the value of x and value of y. For example, see, look here, if I don't want to display all these things, values of x and value of y, I can put here semicolon. Now, if I put here semicolon, the value of x is not going to be displayed on the screen, but it is saved in the memory already. Same thing here, if I don't want to display the value of x, now I can put here semicolon. Now again save it here, again save it. Now if I run it, here, look here, it requires some time to run it here. It is running. Look here. I mean, look here, test2. What was the test2? Test2 was the file name where I have write one program, x is equal to 0 to 100 and y is equal to function of x, which is sine of x. Look here, in command window, test2 coming means that the program is run. The program is already run here. Okay, and it is also completed. But I have put it here semicolon in x range, and I have put it semicolon here in the y values. That's why it is not displayed. Now, our main topics is how to plot it. How to plot x versus y. Now look here, as I told you that here, how to plot it, be careful here. This, if I put the value of x in the first, right? If I put plot x comma y, means this value take the x-axis, right? And this value will be plotted in the y-axis. Now, if I want to put the value of x in the x-axis, so I have to put plot x comma y, means the y value will take automatically in the y-axis. Now let us come up here in our programming now. Now come up here. I want to plot. What I want to plot? X comma y, means I want to plot the graph, right? I want to plot the graph where x will be plotted in the x-axis and y will be plotted in the y-axis. Let us save it here. Now here again, because I put semicolon in the x, I put semicolon in the y, the value of x and y is not going to be displayed. I can get directly the plot, which is x versus y, on the screen. Let me run this program here. Test2 is run here. Look here. Have you seen here? Just look here on the screen. Just look here. Just have a look here. X-axis takes the value of x and y-axis takes the value of y. So now, if I look this figure, it is very simple how to plot it. But in the plotting system, I have just given very simple example at the beginning of this lecture, right? But the figure is not complete. Why it is not complete? Look here. I have to put the x level, means what is the value of x in x-axis? What is the value in y-axis? Means I have to level it. Otherwise, the graph is not going to be complete. Meaning is that I have to write a program in such a way that the x-axis has to be named. For example, velocity. For example, density. Same thing in the y-axis. I want to name what values are taking in the y-axis. Again, the title of this graph. I don't know what is the name of the graph. It means that I need to be discuss the graph completely. The axis should be named, right? That legend should be put here. Whatever the title of the graph has to be discussed in very clearly. Now, before putting all this in details, for example, x level, y level, and a title of the graph, let us try to plot two graphs here. Suppose the value of x is equal to 0 to suppose 100. but I want to plot sine graph and cos graph. How it can be plotted here? Let us try to here. Now next I want to plot two graph here. For example, our next target is I want to plot two graph. This is example number 1 I took here. Let us try to take example number 2. In example number 2, what is my aim is there? In example number 2, my aim is there. Let us try to plot this type of graph. For example, this is our x-axis and this is our y-axis. I want to plot x, suppose y1 and y2 I want to plot. Two graphs I want to plot here. For example, one graph I have plotted here. Suppose one graph, this is for y1. Another graph, suppose I want to plot this. I want to plot another graph here. I want to plot another graph like this. Suppose this is y2. In that situation, how we can do that? How we can do that? In that situation, how I can plot a two graph? Suppose this is y2 graph. In the previous was, it was very simple. I have put x and y, plot x and y. I got this one. Next example 2 is that I want to plot x-axis, the common value of x, but in the y-axis, I have y1 and I have y2. I want to plot the two graphs here. Let us take here, how we can do that is that, suppose x is common here. Suppose x is equal to, again, I took the value from 0, 1 increment up to 100. I put here semicolon because I don't want to disclose it, right? I don't want to display on the screen. Suppose y1 is equal to sine of x. I took this one, and this is suppose semicolon. Again, I want to put y2 is equal to suppose cos of x. Means I have y1 and I have y2. Now I want to plot it. For example, I want to plot y1 in the red color or blue color or green color, and I want to plot suppose a y2 is a red color. How can I plot it? Now plot, very simple here, plot, comma. I want to plot x1 or x, comma, y1, comma. Means I want to plot x with y1. What is the y1? Sine functions. Suppose I want to plot this is a green. So syntax is this is inverted comma z. This plus signify that this this graph will become plus plus like this. This graph become plus plus like this. This graph become plus plus, right? Okay. And what is this z? Z signify the green color. Z signify the green color, right? This is the notation. This is the notation. This is the notation. This is the notation plus. So x comma y1, right? Color of the graph will be green, and it is not a solid line. It is a plus plus, right? This is the concept we can discuss here. Now it is not going to good, so I have here I have here mentioned here. So I want to write here what is z. Z means here green. Z signify here green color, right? What is the plus? This is the plus symbol graph will come. Okay. Now here comma one graph is completed here, right? X I have plotted against y1. Color will be green and notation will be plus. Next again I want to plot this x with y2, right? Comma I want to plot, suppose this is red. I put this is star. R means here red. So I close here. Okay. Now come up here. What I can do here. Here R represent red color here R represent here red color, and this star represent star symbol. Star symbol means what I can get here, this will be star, right? Instead of solid line, I can get this will be in star colors are here. Okay, so X will take from 0 to 100 with spacing is 1. Y1 will be the sine value of X. Y2 will be the cos value of X. Now I want to plot this type of graph. X is common and Y-axis I have two values, Y1 and Y2. Let's see here. X is going to be plotted with Y1 with green color and notation is here plus. Next, X is going to be plotted with respect to Y2 and color will be green and that will be star here. Let us try to write one more program here now. Now this is already we have saved here. I have saved here. Okay, it is set. So I close it. Now open here new script. New script. For example, X is equal to, it will take the value from 0, 1, 100. Or I can put, suppose if I take 0, 2 means the increment will be 2, 2 here. Okay. I don't want to disclose, so I put it here semicolon. Now, what is Y1? Here, Y1 is suppose is equal to a sine of the value of X, right? Here. Next, I want to take Y2. Y2 is equal to cos of X, right? Again, I don't want to disclose it. Now, I want to plot. Look here, be careful here. Plot, comma, I want to plot X, comma, Y1. I want to plot X against the Y1, comma, with, what is the color? I record here, I record suppose green color. Green color, suppose notation is plus here, then I have to close with inverted comma. Here, right? Now, I want to plot here now again X, comma, I want to plot now Y2, okay, comma. What I want to put here, I want to put the red color. What is the notation? Notation will be star here. Now I have to close with inverted comma. Now I have to close with the bracket. Look here, X will take the value 0 to 100. The 2 represented, the spacing is 2, 2, 2 here, right? And Y is the value of the functions sine X. Y2 is the value of the function, and I want to plot X, right, against Y1 with green color. Notation will be plus. Again, I want to plot X against the Y2, right? Against the Y2 with red color here. Now it is untitled, means I didn't save it, so I have to save here. I have to save here. So where I have to save here, that's desktop. Here I have give one folder here. This, that suppose test3 here. It is your choice. The name, the file name will be your choice. Test3 I have put it here, right? Test3 I have put it here. After saving here, I can run here. Suppose I click here to run it. Look here. I can get the 2 graphs here, right? Where the red color represent the what was our program? Just look it. Our red color represent the Y2 figure, and this green color represent our this one. Let us try to little bit modify this graph. Suppose instead of this, let us take suppose 1 itself. Again, save it. Increment is 1, 1. Let us try to look here. Just look the figure like this, right? Where we can get the red to represent the right Y1 and this green to represent our this one. Now instead of this, suppose I don't want to put here plus. Suppose I want to put this is solid line. Solid line is only 1. Suppose here in the red I want to put some dotted line or solid line like this. Both I can put the solid line. Now I can get this type of figure. Let's look here, right? Here I can get the red color is different color, and green color is different color here. Just look here. This, if I put only this, the figure will be solid. Right? If I put here, suppose this space this or this suppose, look here, the figure will be changed here. Let us close it. Let's close it. Now, if I run it, I can get here dotted line, right? Green dotted line and red one. Still, again, we are not able to write in this programming what is the value of x I have taken in the x-axis, the value of y I have taken in y-axis. I didn't disclose till now. Now let us try to write. Let us try to write the labeling. Let us try to write the labeling in the x-axis and y-axis. I want to put some label here, right? How I can put the label of x? How I can put the label of y? Let us try to put it. Let us try to put it, and let us try to do here some new programming where I can put the x label, where I can put the y label, where I can put the grid, everything. I'll show it very clearly here. What I am trying to put here, I want to put here name of the x-axis. I want to put the name of the y-axis. I want to put here some grid also, or I want to put the name of this figure also. How we can do that? To discuss them, let us look in this node. This node is very much important. Just look here. The first column represent our function, which is inbuilt function in the Matlab. Look here. The plot is the functions that it can create a figure. The figure, what is the figure? The figure define a new figure plot window. It means what? This is the figure is a very strong command we have. For example, look here. Here, what is the function of this figure? It is the very important here in this slide. We look here, figure. What is the meaning of the figure here? The figure will do here. If I write the figure in between the plot, what it will do that it will split the figure command, right? The figure command will split the plot in two different window. It means that if I use this figure command, if I use here in the figure command, if I try to use here figure command, suppose this figure command is used in this fixer, what it will create there, I can get two separate graph here. One graph, suppose x and y, suppose here y1, here y1 was the green, so I can get here green graph, right? It is spread in the green and it is spread in the red. Once I use this command, the figure command, it is going to be split in the two graphs. One graph is split in two different window, x and y2 here. I can here now red like this. Now this can be split in two windows. This is window number 1 and this is window number 2. Got the point? What I did in example number 2, I have plotted one figure here. Okay, I have plotted one figure here. Now, if I want to plot these two figures in two different windows, I have to use this figure command. If I use this one, this graph is going to be split in two windows. This is one window and this is another window. So we can get this type of graph. Okay, this is called the figure command. Now, next come up here, grid on and off, create grid lines in the plot. All of us know that. What we can do here, suppose this was our window, right? This is our window. Suppose I want to plot. Suppose I want to put here some grid line. For example, I want to put the grid lines. Okay, these are called the grid lines. These are the grid lines, means I can insert I can insert the grids, right? These are called the grid. These are called the grid. So I can insert the grid line inside the figure. Okay, so just look here. I can put a grid on and off. It means what? If I put grid on, it means this grid will be here inserted automatically. If I put grid on, I can get a grid here. Now, if I put grid off, there will not be any display on the grid on the figure here. So we'll do one by one all these things. Next, X level and Y level. Now here, there is two commands are here. This is called X level and Y level. What is the function of it? I can put the name of the x-axis. I can put here name of x-axis. I'll discuss after how we can put here. I want to put the name of y-axis. Name of y-axis. The name of the command is X level and Y level. Means suppose if I want to put here X, so I have to use the X level command. If I put the value of here Y, then I have to put the Y level command here. Next come up here. Next is that axis. Axis. Set maximum and minimum. For example, here, suppose axis limit. I want to put suppose axis limit. Suppose in x-axis, I want to put 0 to 100. Okay. In y-axis, suppose I want to put 0 to 200 like this. Suppose from 0, 20, 30, 40, and 50. So I can set like this. What is the value of x-axis? I can take 0 to 100. What is the value of y-axis? Suppose 0, 30, 60, 90, 110. So I can put the x-axis limit and y-axis limit. So we'll discuss it with the help of here x minimum, x maximum, y minimum, y maximum. We couldn't put here. Hold on, hold off. What is the role of this? 8 separate plots in the same figure. For example, what is the meaning of it is that hold on and hold off. Hold on or hold off. It means that suppose I have one figure x and y. For example, this is the figure y1. Using the hold on, I can plot here another figure. Suppose y2. Again, use the hold on, I can plot another figure again. Suppose y3. So hold on hold off can be applied here to get the multiple figure in the single window. Okay. Now come up here, listen. Listen means I want to put the listens here. Listens means what? For example, I want to name it. For example, here I can put here green color. This green color is now y3. Now red color here. Red color, this is y1, and green color, this is the green color, this is y2. So this is called a listen, right? This is called a listen. By using the listen here, I can put all these listens here. Next become the subplot. I'll give all the example one by one here, so don't confuse here, don't afraid all these things here. Now subplot. Subplot can divide a figure into several subplots. For example, here, subplot. Spelling should not be mistake. Subplot. This is the command. For example, I have 4 figures. Suppose figure number 1, figure number 2, figure number 3, and figure number 4. So how I can put it? For example, suppose I want to give the figure 1, 2, 3, 4 in this format. Suppose I want to put figure number 1 here. I want to put figure number 2 here. I want to put figure number 3 here. I want to put the figure number 4 here. The subplot syntax is like this. Subplot. I write here M, N, and P. This is the syntax. Now, what is M here? This is number of rows. 1, 2. M represent number of rows. What is N? N represent number of columns. 1 and 2. This represent number of columns. Number of columns. The P represent position. P represent position of the figure. Now, if I want to put here, so P is 1. Here, P is equal to 1. If I want to figure 2 here, here, P is equal to 2. If I want to put here, here, P is equal to 3. If I want to put figure here, here, P is equal to 4. Okay. In this example, what I can get here, in this example, subplot. M represent number of rows. 1, 2. 2 rows. Okay. N represent number of columns. 1, 2. Here, 2. If I want to print this figure, I have to put here 1. Okay. For the next one, I have to go again. Subplot. Same thing, number of row is 2. Number of column is 2. And for this, P is equal to 2. So I can get this figure. Third figure, thus to subplot 2, number of column, number of rows, and 3. Next subplot, number of row is 2, number of column is 2, and 4. So I can get here figure number 1, figure number 2, figure number 3, and figure number 4. Let us try to print this figure here, how we can put all this value and very systematically. What I am trying to apply here, I am trying to use here all the things. I want to use the plot. I want to use the title of the figure. I want to plot the X label. I want to put the Y label. I want to plot again the grid on off. Again, I want to put the axis, lower limit and upper limit. Again, I want to put the legend, suppose temperature, pressure, everything. Suppose if I want to do that, how I can do that? Okay. Let us try to first practice I will discuss this subplot separately. Let us try to do hold on, hold off. I'll discuss the subplot separately. Let us try to do first how I can put title of the figure, right? How I can plot X label, Y label, how I can put the limit of the axis. Okay. Let us try to write one program here. After that, we'll type in the Matlab. Suppose example number 3. Example number 3. In example number 3, suppose X take the values 0 and increment is suppose 0.1. Suppose it is 2 into 5. The phi I represent here. What is phi I? Phi I means the value of phi. Okay. So if I take the value of this, okay, suppose y is equal to sine x. Suppose y is equal to sine x, and I don't want to display it, and I don't want to display it. Now I want to plot. I want to plot x, comma, y. Right? Now I want to put, look here, what I'm trying to discuss here. I want to put here, suppose x. I want to put here, suppose I want to put here y is equal to sine x, means I want to put the name. And I want to put the title here. Title, suppose plot 1. I want to put here. Suppose I want to put here legend. Suppose Lizard is temperature like this. Okay. Now, if I want to take this one, what we have to do here? So now I plot here. Now I want to put the title. Title will be, the command is title. 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 So if spelling is mistake, the command is not going to run here. Title. Title, right? Title here. Inside the bracket, inverted comma. Suppose I want to write plot. Plot 1. It is going to be printed on the screen here. Plot 1. Plot 1 will be printed here. Okay. Next, I want to put the X label. X label. Sorry, the spelling was mistake in the previous, whatever I have written here. It should be A, right? It should be A. It should be B. Label, right? X label and Y label. It should be A and it should be E. X label and Y label here. Now come on here. I want to put here X label. Now, whatever I want to put inside here, I can put the name here. Suppose I want to write in X-axis. Suppose value of X. Then I have to write inside the inverted comma value of X. Close it and like this. Next, come up here Y label. Y label. So whatever I want to write, I should write inside the bracket. Suppose Y is equal to sine X. I want to write in Y axis here. Okay, done. Now I want to put a grid also. Means I want to put here some grid lines here. Suppose I want to put here some grid lines like this. Suppose I want to put some grid lines here. So I have to put here grid on. So I have to put here grid on. It means this type of grid will come in our figure here. Next, suppose I want to put the axis limit. Axis limit, the command is AIS. Axis, okay? First bracket. Now I want to put the first is always limit of X from 0 to 2 5. Because I took here 0 to 2 5. Comma. And Y limit, I want to take -1, comma, to 1. Third bracket should be closed like this. It means that here the value of limit X will be 0 to here 2 5. And from here, it go from -1 to +1. Okay, this is here. Now I have plotted. Title is plot 1, X label, Y label, grid on axis. X limit will be 0 to 2 5, and Y limit is -1 to 1. Now one remaining is legend. I want to put the name of the figure here. Not legends, but the name of the graph. Suppose spelling should not be mistake here. Legend. Whatever you want to write here. Suppose here temperature. Suppose temperature I want to put it. Temperature. Then if I run the program, what I can get? I can get here like this. Okay. And plot 1 here legend will become as a temperature. Temperature. Let us try to write this program here. Let us save it. Let us take a new one. It is not difficult now. Let us try to run. Suppose X is equal to 0 to 0.1 to 2 5 2 into pi, and I don't want to disclose this, so I put it here, comma, Y is equal to, suppose sine X. I can put cos also. Suppose sine X. I don't want to display, so I put it here semicolon. Come up here, plot. I want to plot here. I want to plot. It is x comma y. I want to plot it. Now come up here. I want to give now title, right? What is the title here? Suppose I want to put this one. Suppose write plot 1. Suppose close it and close it. I put the title now. I want to put the x level. So x level. If spelling mistake, it is not going to work. Bracket. I want to put value of x. Values of x. So comma inverted close here, and y level, right? Y level means the name of the y. I can put here. This is, I can put y is equal to sine y is equal to sine x. So I put it here. So I put it y. After y level, I want to put the grid line. So grid space on. So grid will be on here. Next, I want to put the limit of axis. So axis, then put the bracket, put the third bracket. Suppose I want to increase from 0 to twice 5, comma, I want to put -1 to 1, third bracket close, and I have to put this close. Now axis is here. Now I want to put legend, right? I want to put the legend. For example, I want to put here temperature. Suppose temperature. Close. I want to put. So program is to be completed now. So this is already done here. Let us save it. After saving it, suppose I want to put here in numerical methods left. Suppose test 4. Suppose test 4. I want to here test 4. Test number 4. Suppose I save it. Let us try to run this program. It is run here. Test 4 is run. Require some time, maybe. Yes. Look here. Then now look the figure, how it is nice. Now look, let us cross check one by one. Is it coming or not? First, I have put it the title of the x-axis here. What was the title? Just look in the Matlab, value of x in the x-axis. Now go here, value of x in the x-axis. Y is equal to sine x. I have put it here. Y is equal to sine x. Grid on. Have you seen the figure? The grids are on here. The grid on. Next, title of the figure. Title of the figure is plot 1, and this line signifies the temperature. Okay. Now the graph is complete. Now we can see the graph is complete now here. The graph is complete. The value of x, right? X-axis, y-axis, y is equal to sine x. Title is plot 1, and legend is temperature. It is now complete. It is now complete. Now we have to remember that. We have to remember that this is the program how we can put complete graph. Let us come up. Our next is the subplot. Next is our subplot. Let us try to plot 4 different graphs, right? Let us try to plot in 4 different graphs where we can get all complete graph, x-axis, y-axis, x level, y level. Everything is going to be discussed in very clear-cut manner, right? Let us try to plot this type of figure here where we can get everything should be clear here. Okay, now let us try to write one more program with our writing on the display. What is our aim is there? Now our aim is that I want to plot 2 figures. Suppose I want to plot in a 2 figure. Suppose 2 row and 1 columns. In that case, what we can do here, right? Let us come in the next program. Our next program is the subplot. I want to do in the subplot. I want to do the subplot. I want to do the subplot. Subplot M, comma N, comma P. Right? If I have here this, right, number of row, number of columns, and number of columns. Figure 1, figure 2, figure 3, and figure 4. We can do that. Let us try to do here very clearly here. Let us quickly do here one more program here. So let us take here new figure here. For example, using the subplot, right? Let us take the value of x. X is equal to suppose 0 semicolon 0.1 semicolon 100 a column semicolon. I don't want to display here. Okay. Now let us try to define how to plot the 4x4 right here. Let us try to plot here this type of figure, 4 figures. So now here, if I take x is equal to 0 to 0.1 to 100, right? Now I can take y1 is equal to sine x. Let us take, okay. I can take y2 is equal to cos x. I can take y3 is equal to 10x. I can take y4 is equal to suppose sec x, or 10 sine cos 10 or cot, or I can take e to the power x, right? E to the power x, right? In Matlab, I have to write exp x. Okay, let us try to take in this 4 here, 4 figure, our m is equal to 2 here, and is equal to 2 here, right? So I have to write according to the program like this. Just try to write her figure here. Suppose let us take the value of y1, y2 like this, right? Let us try to define here. Suppose y1 is equal to sine x, sine bracket x semicolon, sorry, x semicolon y2 is equal to cos x semicolon y3 is equal to suppose x, suppose square is this kef, the symbol x square, right? X square, right, is signify x square means, right? Suppose y4 is equal to, suppose y4 is equal to exp means exponential. Exp means exponential, right? Yes. So I don't want to disclose all data. So I have defined what is x, what is y1, y2, y3, and y4. Now let us try to use now subplot. Now I have to use now subplot. I have to use now subplot. Okay. What was the subplot? Our it is 2 number of rows, comma 2 number of columns, and I want to put in the position in the first. Means number of row is to this, and first figure I want to plot this one, right? First figure I want to plot this one. So here now plot. This is x comma y1. I have to plot now, right? Now after plotting here, title. I want to complete now title. Title is equal to y is equal to y1 is equal to sine x, right? y1 is equal to sine x. So it is completed. So this is the our title. Now the x level. Now I can put here sine values also. This will be good here. Sine values. Sine values of x. I can put here sine value of x. This is the title. Now x level. X level. There is the X level. I put value of X, right? Values of X. I want to put here. Here value of X. Now Y level, right? Y level will be I can get y1 is equal to, I have to put here sine X, so I have to put this is right. I can put here. Now it is completed. So now I have just put it here, right? I put that plot, right? What is this? Title, X level, Y level. I have completed here. Now for the next program, means I have to repeat same thing for the 4 times, right? Because I have 4, I have to put y1, y2, y3, y4. So same thing I have to repeat. This is the 4 times. Suppose now copy it. Now paste here, right? So this will be 2. Why it is? Now it is becoming the second locations. It's become now the second locations. Just 2. Now I want to put this is not y1 now. Now it is become y2. Now value of X, right? Sine, now it is not sine, it is a cos value, right? Because y2 is cos value. Cos, right? Cos value of its spelling mistake, it should be cos X. Cos X, right? Okay. Let's now come up here. Now value of X, now it is y2. Y2 is here, it is cos X. Where it is a cos X. Okay. Now I have to close it. Now come up here, right? Now same thing, X level, Y level, and title is cos values of X. 1, 2, 3, 4 line. 1, 2, 3, 4. 1, 2, 3, 4, 5, 7. Now it is completed. Now again I have to copy this here. Now copy it. Now come up here. Copy paste. Now I'll go for the third locations. It's P is equal to 3 here, right? Now come to third locations. Now here P is equal to 3. I have put it here. Now it is not plot. It's something. It should be y1. Be careful that it is y1. This should be y2 now. It should be y2. Okay. Now it is not cos. The x square values now, right? Now I have to put x square values. X square values, title X square values, right? X square values of X. Suppose I want to put here y3 is equal to X. Again, I put F2 values. So plot third positions. This should be y1. No, this is y2. Right? No, y1. It should be y2. Y2 is cos. Y3 is x square. This is for y3 for x square. Right? It is complete. Now come for the 4 positions. Now come for the 4 positions, but 4 figures. Come up here. Now it becomes location 4. It becomes location 4, and it should be now it is y4. Now it will become y4. Now it is exponential value of x, right? Exponential value of x. Exponential value of x, right? Exponential values of x. Okay. Now next thing, value of x. It is exp y4 is equal to y4 is equal to exp x, exponential value of x. We can get all these things. Now I can put here a grid on everything here. So in the last example also we have put a grid on everything here. After the y level I can put here grid on, so I can get grid on here, right? I can put here grid on. We put that here grid on means I want the grid in the figure. Again here I can put here grid on. I can grid on every here I have activated grid here, right? I can here grid on. I have now next. If I want to display the x-axis, I can display this. Now I can represent now legends also, right? Now I want to represent here legend, right? I should put here space here. Now after grid on, suppose I want to put legend. Suppose I want to put suppose first one is value of sign. Suppose sign values I can put here. Sign values, it can be put it here. Now every time I have to put for all, for second floor here after grid on, I can put legend, not the capital. This is legend. I can put here, not legend. It should be legend. It should be legend. Here, of course, the cost values, right? Cost values I can get here. Next I can get here after grid on, I can get here legend. I can put here again the square values of x, right? I can put here square values of x. I can put here. I can get here. Okay. I can put here after that last exponential. I can put in a legend. I can put here. I can put here inside the bracket exponential values of x. I can put here. Now I can put the axis here also. If you want to put the axis here, again, I can put here some red line, green line. Suppose I want to put here red, green, everything I can put, but it will take automatically here. Now just try to save it and try to run it. Test 4, right? Numerical methods, support test 5, which is the test 5. Test 5. Test 5, I want to run it. So now if I run it, the scale it is, I should put here dot syntax because it is the vector multiplication. So I put here dot. Okay, now how it is going to be on here. Yes. It records something. Look here. I have got the 4 figures. Now, see, it is very clear cut now. First title, sign values, cost values, x square values, and exponential values. So title is clear. So listen is sign values. Okay, sign values. I can get here cost values, exponential value of x, square of x. Now, if I'm not putting the here the limit of the x's, it will take automatically. Because it is very simple to take the value of x-axis in the limit, but y-axis we need to calculate how many values it can take here. So now, accordingly, whatever we have designed here, ultimately we have got in our calculations here. Okay, so now how nice it can be represented here, right? So we have used the subplot today here. Now today I'm going to stop here. The next class, guys, in the next lab class, we are trying to plot some more figure. For example, a phi diagram, bar diagram, and it is a histogram. Okay, in the first or last class, part number 1, we have started some basic of the plotting system. In today's lab classes, we have discussed how to use the different type of legends, X level, Y level, and titles, how I can put the grids, how I can label the X-axis and Y-axis, and how I can use the subplot. It has been discussed in today's class. So I hope you have understood here. Next class, we'll discuss some more plotting, some more graph. I hope you can enjoy in the next class also. Thank you very much. Today, we have stopped our lecture here only. Thank you very much. Have a nice day.